And now a little bit about the concept. You can hear here is a background noise. It is machine electronics, this small fan, 40mm fan. I would say it's about 30 decibels maybe. Anyway, for normal environment, it's almost silent. And when you operate machine, then maximum noise is like that. Yeah, this is spindle full speed. I would say it's decent, and the spindle's full speed is about 60 decibels. It's a speech level, and you can withstand that noise for a long time. It's you can use it in open without box, and that's nice. Okay, the goal of this topic is not to teach how to use a GRBL software. I would like to use an option and say thank you to all those guys who built it, because it solved a very important niche. If you are doing no kind of open source PCB building, you're always lacking good software to use it. And with this GRBL candle software, there's some variations of that. Significant even business area. This is stable, this is a good software, it's well built, smart guys did it, and I really appreciate it is useful, especially for PCB usage. You can do practically everything for PCB milling. It may be a bit short for some really professional works when you are milling metal and aluminium parts and you need to do a lot of stuff with tool exchange. Yes, then you need a more advanced software, but for simple educational and PCB milling, it's almost perfect. A little bit about the concept. You can see here is the user commands. And that's important. You can view them in the settings. If you don't see, then enable on the panels user commands. But in those 4 buttons, I'm setting some basic commands for easy operation. One is go to XY 0 coordinates. Another one, I use this when I need to exchange a tool, that it goes a little bit left and handy to exchange a tool. And this is, and those coordinates are, after homing, I'm setting them exactly on the center of the bed. So I actually start to make a bed based on those coordinates, and then another service coordinate. But you put but those coordinates are handy, especially this one is important. All our works starting from homing cycle, and as I mentioned, I was impressed about homing limit switch tolerance. You can get a confidence 10 microns. Confident, yeah, it's repeatable. Confident 10 microns. Always you have at 10 microns homing precision, and then when you finish a homing cycle, then you set it's 0 XY, you are at 0, and then you use this service command going to center of bed, what you made. And that means you're always at center of workpiece, and then based on those coordinates, I'm working with the central coordinates, not the corner coordinates. I show you it, it's here. I'm always working with the center of material. That gives several advantages because there are commands put in a center, and then I'm dealing with all layers and vectors. You can see that I imported all layers, like top and bottom. I can do many things here. It is easy to work with the vectors. I can mirror it, I can put it, I can see in the layers. Just since I have such a license, it is better to work with a professional software dealing with the vectors. But you can do it with a Flatcam. This is a Flatcam. I'm using that Flatcam only to generate geometry, and then I'm exporting it to to the DXF files, and then those DXF files I'm importing here in this software. But of course, you can do practically everything with a Flatcam. There are several tutorials and educational stuff in YouTube. You can do whatever you want. What is a minus of Flatcam? Pretty clumsy with a vector editing. It's not that easy. But otherwise, if you have well prepared Gerber files, then you can use Flatcam to generate G code. And here you can see that for dual-sided board, you should mirror bottom side, and it is mirrored. You can see those holes doesn't match. Those are in mirrored way, because I'm drilling from one side, and then the bottom is the last one which I'm processing. So with the top side, drilling holes matching, yeah, they're actually matching very well. And this is also for a tests when I'm making such complexity board, then you can see everything. This board is meant for 0.3 millimeter drills. Yeah, they are vias with a 0.3 millimeter size pads. For prototyping, of course, you are not working at that tolerance. Coming back to Candle software. So those buttons are important, and you also need a height map, and I have a height map as well. This is a real height map what I made, and I found out that it is better to make a height map with a 3 millimeter flat type mill, which I'm using for pilot holes. I will show where they are. You can see that those are reference holes here in the sides. Those are pilot holes for 3 millimeters, and those always are done first, and then I use the same mill. It's done with this specific flat type mill. If I find a picture, I will show you. And then I'm doing that height map. Here is a height map, and for your reference, in a central part, there should be double zeros. If there are double zeros, then everything is fine. Very high tolerance, and you can see on the edges where you a little bit push. Your flatness is not perfect, and this is why always you need a height map for any job what you do with a PCB milling. Additional. Sometimes it takes, you can see this height map took about 20 minutes for all points here. I'm doing it relatively precise, and it pays back. So it's not like you can make a PCB in 5 minutes. It's a lie. Normally you should count 2 hours for a PCB. That's a realistic time. You need to think, you need to do all things in a proper sequence. You should find the right tools, and everything should be handy, and then I'd say always count the 2 hours, and then you get it. Yeah. In my opinion, to get PCB in 2 hours, it is fantastic result, and it doesn't mean that you can't do anything else. You can read your emails, you can watch with one eye, just is it everything fine, it's nearby your work location, very easy, crazy handy. Regarding dust and the dust collection, fiberglass is unhealthy, silicone dust, and I'm using mineral oil. You can use even baking oil for that, and then this dust all is in oil, and also it is oiling your mill, and mill is working longer time. Actually, I'm using some specific mineral oil used in professional milling with dilutes in water, but you can use any of them. There are plenty of examples in YouTube how to do it. and then you don't need the dust extraction. With a milling PCB outline, then I'm doing in monitored way and using standard household vacuum cleaner for those, I don't know, 5-10 minutes, what is needed to mill it out of the milling that outline. This is manual process, but also it makes your system so light and easy. You don't need too much surrounded with many additional equipments like a vacuum, like a dust extraction, some specific measurement tools and many other things. System is really simple, and you can do, I would say you can do 6 mils PCB. Fantastic result and great simplicity. One more thing I can show you, it may be valuable. There is such thing as a GRBL settings pocket guide, and it could be valuable to you. There explained all those commands and data. And sometimes it is important to see what kinds of settings you have. There is it is double, I don't know the English name of it, double dollar sign, I think. You put a double dollar sign here, push enter, and then Control A, Control C, and put in some note. And you can see all settings what your machine has, and I want to show only 2 of them. $100 and $101. Those are calibration values. You can see that normal they should be 800 steps for a predefined distance, and I have 802, and then I have perfectly precise steps and distance. And summarizing, I would say this is perfect software for PCB milling. How you deal with the vectors, as I mentioned, you can do it with a Flatcam. It's also free of charge software. In case you have some commercial software, you can use it. The main thing is at the end you should get a G-code to execute your PCB milling. I'm using that Vetrix. I have a license for that. It's old version, but it is fantastic software to deal with the vectors and other stuff. Yeah, it has 2 parts. It has one part where you can dealing with vectors and drawing everything and editing, and the second one is where you are making your G-code, setting your tools and doing rest of the things. You can do the same in a Flatcam. Not that handy, but you can do everything. And this team who made a Flatcam also did a good or contributed very well to community. And with those two softwares, practically you can make a PCB at professional level. That's it from now. Maybe later on I will film some complicated PCB milling in the future. But I think this part is by far more important than watching how programmed device is milling something. Especially that process is relatively slow and boring.